All right, here we go. Question number 11 from our Calculus 1, homework number 1 in WebAssign. They want us to use a table of values to estimate the value of the limit correct to 3 decimal places. If you have a graphing device, use it to confirm your result graphically. And so I'll try to throw in Desmos at the end to at least address that part of the problem. So if we're going to make a table of values, if we zoom in on this, we can see that our function is sine of 7 theta divided by tangent of 4 theta. And so I've got my scratch pad open here. And what we need to do is we need to pick some values of theta that approach 0. And we need to pick values that approach 0 from both sides, so from the left and the right. So let's say, for starters, how about negative 0.1 is pretty close to 0 from the left. Getting a little bit closer would be negative 0.01. And then finally negative 0.001. So those are 3 values that approach 0 from the left, getting closer towards the middle. And as a math person, I like symmetry. So on the other side, we're going to say 0.001, 0.01, and 0.1. So again, those get closer to 0 from the right in this direction. And now all we need to do is pull up our handy dandy calculator, make sure that we're in radian mode. And I don't know if you can tell that, but there's a little R right here on the calculator that indicates radian mode. And we're going to use the calculator fractionability, sine 7 theta. So that is 7 times negative 0.1, and then over tangent of 4 times negative 0.1. And we're going to write that down. Now remember, it said to 3 decimal places, so I'm going to write down that value rounded to 3 places, 1.524. And then with the Casio ClassWiz, it makes it super easy to edit what we entered. Instead of having to type the whole thing over again, we just edit our thetas to negative 0.01 and recalculate 1.748 rounded. And if we do this one more time, throwing in another 0, 1.7499. So that would be 1.750 rounded. And then the easiest way to do the rest of these, again, is just edit, and we're going to remove the negative sign. Oh, and we have symmetry, 1.750 rounded. Let's see if it's symmetric for the other ones as well. 1.748. And just for fun, I'm pretty sure it's going to be symmetric. 1.524. Yeah, so we have symmetry. Now, look what happens as we approach 0 from the left and right. It appears that we're getting close to 1.750. And I think if we added more zeros, in other words, if we got even closer to 0 from the left and the right, that this value would end up being 1.749999, lots of 9s, which would round to this value. So now what we want to do is we want to go to Desmos and verify this result graphically. And so here in Desmos, you can see that I've entered our function. Instead of theta, I used x, and this looks crazy. And remember, we're concerned about the limit as theta, or in this case, x approaches 0. And so what we want to do is we want to zoom in, being careful here. We're approaching 0 from the left and the right. And this looks like the value that we're approaching. Notice it is actually undefined at that point, but we don't care what happens at the point, we care what we're getting close to. And so if I zoom in enough, you can see that Desmos gives us that value of 1.75 that it appears that we are getting close to. Again, zooming in a little bit more, you can see that we're approaching 1.75 from the left and the right. And so going back to our WebAssign, we're going to input what we think is the answer. And I'm going to go ahead and put the 0 since it says to 3 places and see if we're right. And bam, we got it. And that's going to do it for this problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.